Okay, basically, this is a follow-on to the previous presentation. Just to oops. More or less, we have the same playground because we are here. So the idea is the following. Here, we are analyzing only a part of the traffic, okay, the one that goes to and from the internet. There are many people who are on the backbone here that, as I said, is running a gigabit at the moment here, 1 gig. You see they have other boxes. And those people need also to analyze their own local traffic, because we only track traffic that goes to from the internet. But also we would like to see the local traffic, what's happening here. And because we are here, we have to delegate this activity to other people. So we said, why don't we use NetFlow or Similaria to have some accounting, some figures, not only for detecting problems, but also for doing some accounting. Say how the bandwidth is used, if there is something wrong, who has to pay. Okay, if we have to announce this box, who is going to pay for it? Who are the most users? Is the technical department, the engineering, the administration, and so on. So we said, let's use NetFlow. Everybody has accepted it as a standard, more or less. But with NetFlow, we have a problem. The boxes, okay, are very fast, are able to switch millions of packets per second. But when they have to generate flows, I'm talking about Cisco, Extreme, and Juniper, they are running into troubles because they're not able to cope with the network speed. They take a sub-portion of the traffic, probably around 10,000 packets per second, and they generate flows out of them. And this is a problem. So we are not happy because you can definitely use those flows for having an idea of what's going on, but you cannot really do accounting. So we need a NetFlow probe for a gigabit network. So that's why we decided to develop this. That is called nProbe. It's a software probe that you run onto a PC that receives traffic from a mirror port, in our case from a Juniper, but you can put a hub or whatever you want. Okay, of course, at Gigabit you have probably this facility, but you can tune the switch to mirror you the traffic, and then to generate flows out of it. So as I've said, Cisco NetFlow is a commercial standard for network monitoring. Everybody knows it. Many companies say we are NetFlow aware, but more or less this is just commercial stuff because, as I've said, they run into major troubles. For instance, Juniper can handle up to 7,000 packets per second, although the switch maybe is able to switch 1 million packets per second in your network. But only a sub portion of the traffic is used for generating flows. Everybody knows that if you turn on NetFlow on Cisco's, basically the performance will go down. Or if you install these MSFC cards, you run into trouble with configuration, okay? Because probably some of them are really not able to operate in your network because you have a certain configuration that the card doesn't like, or you see just a part of the traffic. So you know that on the internet there are many collectors available for NetFlow because the idea is that you have the router that sends you the flows, okay? There's very little offering on the probe side. So there are not probes, basically, just a few of them. And the problem is that NetFlow monitoring cannot cope with gigabit speed. And there is an alternative named S.p.A. that is becoming more and more popular. But the problem of S.p.A. is that it's limited to a few companies, basically just to foundry networks, okay? And S.p.A. is good, but doesn't have everything that NetFlow offers because it uses statistical and packet sampling. Also, NetFlow is supported on high-end routers. So if you have a slow network, if you have ADSL, if you have somebody that doesn't have a high-end router, you cannot enable NetFlow. And also, because of this, many people are still using MIP2. Okay, you run MRTG on the interface, you draw the graph, you see a peak, and then you say, why? You don't know. You don't have a clue. Because this is aggregated information. ARM is relatively used and very difficult probably to install and to use. And most of all, it's very expensive. So our solution was nProbe plus nTop. So basically, we want to be able to give NetFlow another chance, okay, to let it work 4 gigabit network without having to buy very expensive cards, because those MSFC cards cost thousands of euros. We want to be able to run at gigabit speed, so at least 1 gig with no packet sampling. So if we do some packet sampling in future next, so probably 10 gig, you can do 1 to 10, and you're fine. And we want to be able to have something really open source for everything. nTop is open source, nProbe is open source. So generate the flows and collect the flows open source. So the main features of nProbe are, first of all, that it runs on both Unix and Windows. That's very important. Second, I said is able to keep up a gigabit speed. And third, that it doesn't use a lot of CPU or a lot of memory. Okay? So we are able to have good results. So basically, just to give you some figures about the internals, there's one main thread that receives packets and store them in a hash. Okay? And there is another thread that periodically walks the table and emits expired flows. The hash is static because when we start, we want to know how much memory we need. And this is very important for embedded systems. I'm going to show you later. So I start, I allocate the memory, and then I do everything with that memory. No malloc, no free at all. So we don't lose time with malloc and free. And we know that if we start, we're able to work. Of course, somebody may say, OK, but what about BGP? Inside NetFlow, you have information about the autonomous system. So the traffic is coming from this AS, is going towards this AS. In order to solve this problem with nProbe at the moment, we're using a file. So we extract information out of a router. There are several scripts that allow you to do this with Cisco. They are on the internet. If you buy a Juniper, for instance, there are some demo scripts that via JunoScript extract the BGP table. Somebody may say, OK, but the BGP table changes over the time. Yes, but I assume you don't want to monitor end-to-end AS, but you want, so the origin, but you want to monitor the peer. You want to see how in your network this traffic is flowing. Is it going towards provider 1, provider 2, or provider 3? And the BGP table in your table probably doesn't change very often. Or even if it changes, you just have to extract it again from the router, save it into a file, and restart nProbe. So we also have BGP information, although we are not inside the router. Very briefly, some figures about the performance. Those tests have been performed with an AgILink router tester, model 900. And we use Linux, dual Athlon 1.6 gig, Intel Pro 1 gigabit Ethernet card, normal Linux, no tuning, no nothing. We decided to use the drivers that are provided by Intel, not by Donald Becker. But that's a secondary issue. So basically, those are the figures. When we have a packet of random size between 64 and 1,000 bytes, we are basically able to run at full speed, 953,000 packets per second. When we have small packets, we run into trouble at the moment. I have not mentioned that this application is based on lib pickup. So basically, the packet is sent to the user space, collected, and we do something with that, like many sniffers and many other applications are doing. So their figures are great because, as I said, here, this is basically the maximum you can achieve out of 1 gigabit Ethernet. Okay? But if the packets are very small, then we probably have some troubles. Modern networks tend to have small packets. For instance, in telephony, okay, those cellular phones, they have small packets. So we have said, OK, those figures are great, but they are not what we want. They are not the final goal. This probe is perfect for many people. Okay, if you have a 100 megabit network, you install it on a normal Pentium 2, Pentium 3, something. Doesn't use much memory, a few megabytes, 3, 4 megabytes. It depends how large is the network, and you're done. No major problems. With gig, we have some limitations. So we have decided to do something more. First of all, we have decided to create an embedded appliance for this. Because if you have your network, you probably are scared of having a PC, installing the software on it, and probably moving the PC to the place where you have to monitor the traffic, especially if you have small departments of people like, they're not computer scientists. You don't want to give them a PC, a monitor, a cable, and they have to turn it on. You want to have a small appliance. So we are working at an embedded nProbe is applying name nbox. I will show you some pictures now. On the other hand, we are not happy about the information that NetFlow is sending us. For instance, NetFlow doesn't say anything about MPLS or VLAN. If you have VLANs or MPLS, you don't have this information. No payload, and also we would like to have some sort of security, so know whether the flow we see is generated by us or by somebody else. The NetFlow count is not enough, of course. And of course, some compression. So these are the current research topic. And just to give you some information about the availability, here you can find the probe, the software probe. We are now trying to create a version of the probe that runs inside the Linux kernel for better performance. So we already have some prototypes that are performing very well. So basically, we have moved the probe from the user space to the kernel space so we can run at full speed, and we send towards the user space the flows using a memory map, so some memory that is shared between the user space and the kernel. And we're achieving good numbers, good figures. So far, we're able to go at full speed. So namely, the limitation is the PC. Okay? It's not we are wasting time copying packets, doing system calls. This is solved. The problem is the PC. So how fast it can handle interrupts. Okay? How fast the packets are arriving, and this machine is able to handle it. Second, nbox. If you follow this link, you will find something like a cigarette box, as small as this. It has two power PCs inside, an embedded power PC, 800 series. It allows you to monitor slow network, up to 10 megabit per second. And this is good for many people who have ADSL, for many people who don't have a fast connection, but even HDSL is fine. You can monitor it properly. So at the edge, you can generate flows that you will send to a central repository for doing your monitoring. And this appliance is very cheap. And then at the end, if you want to visit this site, nflow.org, you will see a specification of this new flow format we are now trying to push. nFlow at the moment is supported by nProbe, so nProbe is able to emit flows, both NetFlow and nFlow. If you go there, if you go to the site, you will see what's interesting about nFlow, okay? Why we have created it. As I said, we have information about the payload, we have some compression, we have some security, and most of all, we are able to support IPv6. NetFlow doesn't know anything about IPv6. If you have an IPv6 network, you cannot do accounting using NetFlow. And you're able to do this with this. As I said, it's supported by nProbe. That's all for now.
Are there any questions?
What do you do with the collected information? Do you export to another station, another software, your software, or some common solution?
Okay, of course you can use whatever collector you want. There are many available on the internet.
It's a standard approach.
Yeah, but we tend to use nTop, and so nTop is able to collect packets out of the internet, the adapter using pickup, but also to receive NetFlow probes, NetFlow flows. So, in our view, we want to provide both the probe and the collector.
You seem to rely on duplication of packets on a switch. That means you can't handle all the other kinds of interfaces you could expect on a router, like a POS interface.
Like?
Like a POS interface.
This is not correct. There is somebody from Gigabit that can explain you. One of the good features of this box is that it's able to monitor IP packets that are running on SONET, SDH, or ATM in our case, on an Ethernet interface. So my probe is able to see those packets, although they're running on something that is not Ethernet. So in my example, I've shown you ATM. Okay, IP over ATM. My probe receives the packets, and this work is done by the router. Because if the router has to route ATM to Ethernet, then it has knowledge of the IP packet. And we basically delegate this to the router. Just to give you some figures, with this approach, we'll be able to monitor ATM. I don't have POS, but you can do exactly the same. Over the Ethernet, you attach the probe, and then you have whatever you have. Not important. This comes for free. It's an embedded...
I have a comment regarding your statement that you cannot monitor IPv6 with the current NetFlow. Yes, you can if you use the version 9.
Yeah, but who's deploying version 9?
It's an approach to a new NetFlow. And for that one, probably, how is it related to the NFlow specification you have done to the IPFix working group of IETF?
Yeah, but I agree with you. But there are two problems. Okay, first of all, NetFlow v9 is not deployed. Okay.
Yes.
You have, okay. Second, you don't have free collectors. People that are creating flow tools said, as soon as we have NFlow v9, we'll do some support for it. But it's not very clear what's going to happen. IPFix is somehow in the limbo. We don't know. I need this today, so that's why we have created. But the problem is, what about the rest of the features? I don't want to sell it. It's free, nFlow.org. But what about the payload? I would like to know in my network how many people are sharing MP3 files or how many video files are sent to the internet. If you don't have the initial payload, you have no chance of knowing it. Many people say, okay, peer-to-peer, we block it. How can you block it? New protocols are smarter and smarter. If you don't inspect the initial payload, then you're in trouble. Also, as you know, new protocols are encrypted, obfuscated, whatever. So this is a challenge, but I agree with you.
Yeah, just one remark. If you ask such a requirements for the IPFix, probably they can somehow integrate your solution in the next flow monitoring thing.
This is what I've done, and so far I got no reply. Probably my email is wrong. Let's see. Okay.
It's very interesting and quite elegant, but would you not have to add to the cost the cost of mirroring traffic on a gigabit port, which is not insignificant on let's say a Juniper router?
Yeah, I agree with you. It doesn't cost, but if you have a gigabit router, you have money, no? Don't you? Yeah, but don't forget that Juniper, in my respect, it is free, because if I have the network, I must have the router somewhere, so I don't have to pay for it. I have to pay for an additional peak, and this is true. This is true.
Okay, thank you very much again.
Thank you.